My name is David Goodstein, and I'm a webinar coordinator for the Outsourcing Institute. It's our pleasure to be the co-host of today's event with Luxoft. I'll be working in the background to help answer any technical or general questions that you may have. Before we begin today's session, I'd like to quickly tell you about the questions box. We encourage you at any time during today's presentation to submit your questions to today's speakers. To do so, click on the questions box, type your question in the space provided, and click the Submit button. Today's webinar will be recorded, and you will be receiving a follow-up email in approximately 2 days, which will have a link with today's recorded webinar and presentation slides. The webinar recording and presentation slides will also be available at outsourcing.com. Before we begin, I'd like to quickly say a few words about the Outsourcing Institute for those who aren't familiar with us. The Outsourcing Institute is a professional association dedicated to providing independent best practices, tools, roadshow events, networking opportunities for all forms of outsourcing. Located at outsourcing.com, we have 70,000 members globally. OI specializes in providing low-cost and no-cost alternatives for outsourcing buyers in need of RFP tools, vendor selection assistance, training, as well as general support and coaching. For those of you in this market, we offer an array of very targeted sponsorship and promotional opportunities. Our sister company, CMS, provides recruiting services for those seeking to hire outsourced professionals experienced at buying, selling, managing, or consulting in this arena. Our contact information is at the bottom of the screen for those who have any questions. So at this time, I'd like to turn it over to the moderator, Tony Mataya, Managing Partner at ThinkSolutions, to introduce speakers.
Welcome, everyone. I think we have a great topic today, very relevant for a lot of people out there who are dealing with big data issues. We've assembled a great panel that I think can bring a lot of good information to and relevant to what you're looking for. Myself, I'm an advisor to the Outsourcing Institute, and I have 25 years experience in IT. And one of the things that I try to do is make sure that you get your questions answered. So please submit your questions, and that way I can work with the panel to get those resolved. My background is in IT, as I said, starting with IBM, Pricewaterhouse, working with TPI, and then starting our own firm, ThinkSolutions. We do advisory services for clients who are looking at transforming their business through outsourcing or other tools. And with that, I'm going to turn it over to Sergey.
Hello, everyone. My name is Sergey Bakulin. I'm from Technology Strategy Center in Luxoft. I'm responsible for all the innovation in our company. And my background is I'm from energy sector, and you know that's pretty free, maybe 4 years. Energy sector is moving to big data problems, and right now I'm trying to leverage my experience in the energy sector, processing huge amounts of stored and streaming data into other sectors. And I'm passing to Vadim.
Yes, hi. So Vadim Lasenik, so I'm a managing director for Luxoft and responsible for Europe, our European operations, so key business development, also in charge of one of the largest investment banking engagements in London. And also I'm in charge of developing big data practice in Luxoft. So I have over 20 years of experience and technology experience, and where it's in various roles from product development, senior architect, and actually heading some of the business units in investment bank. And basically later I joined Luxoft, which is basically doing service for those big enterprises. So, and let me actually start the presentation, and if you can go to the next slide. Yes. Okay. So I know that the V is widely known as a big data definition. I still want to go through it just to have a background and also to maybe refresh it for all participants. So big data is a collection of or set of data which is such a big one, so that current practices, current technologies do not support processing or analyzing the data using traditional technologies. And just to to maybe reflect on those categories in enterprise environments, big data or volume of data becomes, or it was kind of big all the time, but enterprises were ignoring lots of data because it was no processing power before doing it. Also, the current environment, current business encouraged to get more of this data points which can be then analyzed, and actually this data can be used to take it forward and create new business models. Then the second one is velocity. So the data coming in a very very high speed. And this data needs to be processed quickly, otherwise it will be lost. So it's technologies, media, finance, government, healthcare. All of those areas actually have this increased velocity of the data. And the other one is variety. So it used to be that the data enterprise was all structured, all relational. Now it's a need to go and actually have this data coming from all different sources, coming in all different forms, being enriched and used for analysis, for actual decision making. So if you can go to the next slide. Okay, so big data response. So yes, we have this big data definition. So how we respond to it? As I mentioned, so we have this wide range of different type of sources, volume and also velocity, and at the same time, the organization that basically supporting big data is a big challenging task for technology, so storage processing, but also the way how you analyze the data. And it does require a new application development platform, new application development pattern to come up with this technical solution. And then, so we'll actually be able to extract the business value. So, so talking about the business challenges in particular, this exponential growth of data making prohibitive to use traditional technology to actually process the data. So if you take some of those before this called big data infrastructure evolve, then it won't be even possible. Then the next one is, because big data now not only technology platform, it's also now becomes part of business strategy. So if you don't have ability to do it, you will not only not be able to be a leader, you actually will start losing your market position. You'll be losing it to your competition. And the other one is the range of technologies to offer solution for data problems, so big data problems emerging daily. And actually selection of the solution is really becoming a task on its own. And finding like right expertise becomes as challenging as ever.
Next slide, please. And if we speak about the problems that just Vadim mentioned, they have already been solving somehow before the big data problem arrives. And for sure, there is some ways of making it data flows within the enterprise. It all starts with data sources, the data then being prepared, transformed somehow, and being analyzed with traditional tools. And you will notice, by the way, that in this presentation we will be referring to traditional and after big data in almost every slide. And here the presentation is the same. And if we start, no, it's okay. Let be this. Press the next slide button. Yeah, Tony. No, the first one.
That's okay.
Oh, that's okay. Anyway, so what did we want to mention here with this very fancy animation is that we're gonna show the position of the technologies that can process the big data like Hadoop within the data flow and matching that to these triple V's. And it all starts with variety. And the main feature in variety is that you don't just have different kind of sources of data. You also have two worlds of data, structured and unstructured. And if you experience huge amount of relational data sources, it's pretty easy to handle that with traditional tools. Like imagine your utility grid that processes information from all the telemetry sources. But as long as they try to process information from social media, information from the documents, the current tool cannot work effectively. And if you please press the next button, we will switch to the data preparation and transformation. And here the main part of the Hadoop effectiveness appears, because when you go to the traditional tools, in a big data world, you will face the large volumes, so the second V in a huge scale. And traditional tools, they can scale, but sometimes the cost of this scalability is enormous. And the scalability in terms of performance, in terms of the cost of data storage, in terms of changing the logic, everything goes here. And if you go to the next slide, we will go to the integration with advanced analytical tools. And again, the more sophisticated analytics you have in a big data world, the better are the results, because in analytics, the more data and in a more sophisticated way you can analyze, you can correlate different data profile or different data. Thank you. Does anyone hear me?
Yeah, coming through now.
I can hear you now. We have a heavy echo.
Yeah, now it should be better, I think. Yes?
Sound great now. Go ahead.
Good. Thanks. So this is it. So this is the place for Hadoop. Transforming the way you operate with a variety, with large volumes of data, and advanced analytics. Next slide, please.
So, and the next slide shows you the current big data landscape. And this is just to show you variety of different solutions. As I mentioned, they're coming up every day with new technologies, because everybody do realize the value of ability to implement actually processes big data. But then this technologies is quite new. They're emerging. They provide a wide range of solutions. But one of the things which we experience when we implement those solutions is that those components, not all of them, some of them, could not be easily adapted to enterprise-grade infrastructure because of the requirements of security, reliability, availability, and actually selecting right tool, selecting right technology, right pattern for usage. It's basically a big challenge on its own. And even the companies which start doing it some time ago, actually the pioneers of this adoption, they still have, they still go through this development of new pattern cycle, because it's still so new, and the challenges which enterprise have to adopt this new technology is still there. So if you could go to the next slide. So, and this is just to give you an idea. And again, for many of you, it's unfamiliar, but just conventional architecture, it's where you have all this high availability, talking about enterprise, of course, high availability clusters, VRs, and it's all having standard solution for those type of things. And each of the box or has its own purpose, and actually to provide this high availability solution for enterprise, you need pretty expensive set of hardware and network equipment, etc., etc. So then, if you're talking about this next big data or post-traditional architecture, then it's slightly different. So you actually move from sequential processing to parallel processing. That's the whole idea of big data. You're actually using completely different set of hardware, so it's now becoming commodity hardware, or it's actually cloud solution. And you're not talking about servers anymore. You're talking about clusters or platforms. So that's another change which you need to adapt to. So you can go to the next slide.
Yes. Just imagine that you go to your IT department and say that in your data center you stop buying IBM System P, and instead of that you deploy 55 cheap computers and a lot of network equipment to balance the load and transfer data from one to another. He will ask you a lot of questions. Okay, how are you going to monitor this mess of the new computers? Who are the vendors? How do I manage them? What are the tools for management? Do I use the same tool for all of them or different tools for different purposes? How do I provision all those Hadoop clusters? These are a set of questions that are normally asked every time you try to deploy Hadoop infrastructure within the enterprise, because when you go to startup, it's much easier. Then you go to the development team and you say about the new data silo that you have. They can use in different applications. And they ask you another bunch of questions. How do you integrate with my Oracle ESB? How do you integrate it with SAP? Do they support transactions? Do they support rollbacks? What are the security restrictions, and how do you integrate all this kind of software? There's a lot of questions that you need to be prepared to answer before you move into deploying Hadoop for the enterprise. And not to mention disaster recovery, which is completely different story for the infrastructure Vadim just described. So just be prepared. The infrastructural questions will be arised, and you need to have these answered before. And next slide, please.
Okay, and so the next part of the presentation, we'll go through all of those challenges and describe them, because it's probably one of the most interesting parts of this presentation. So when we talk about enterprise adoption, we see three big areas where we see those challenges. Here, the first one is adoption of new technology and techniques. Then it's because the technology is new, it has a new concept, new foundation, so it's kind of new generation. The next one is supporting the organization, because the platform does provide you a completely different set of capabilities, and it requires also new skills, and it requires skills from business or analytical side, and also in technology. So those kind of complete transformation of the organization, actually, or addition or adding some to it. And the last one is rebuilding IT infrastructure. So moving from traditional high cost servers to this new clustered environment. It's another one. So it needs to be changed as well. So you can go to the next one. So now Now we talk about first technology and techniques. So is the first category. So let's talk about basically compare legacy, so before big data and big data approaches. So some of this information we already went through when we present you the slides about the solutions, but I want to really focus on those points, and then when we go to a case study, we can discuss them again, what they are, how they are solved. So talking about data transformation and storage. The current data transformation and storage implementation, implementing new formats or data requires, it's basically expensive, costly process. So you would need for every data source, for every change in your format of the data, write specific ETL, which actually takes the data and puts it into the data warehouse. And on the storage solution, you were not able to actually create one solution for all data. Every time you change your business or you have new data coming in, you have to do this design session. You have to adjust your data solution. And usually it's all those data solutions, they're aligned to the business units, and actually leads to creating multiple systems and data storage, multiplying them all over the enterprise. And so that's a landscape of the legacy system. So for some of our clients, we have thousands of those systems, and like tens, hundreds of them using the same set of data because they need to have like this in particular format, or because they have the particular business need or producing reports. So this is the legacy way to do it. So big data allows you to do this transformation on ad hoc basis. So it has technology like MapReduce. It allows you to work with this technology on top of all different data. So it's raw data, semi-structured data, and structured data. And talking about how we perceive the data, so the concept of data reservoir for the whole enterprise is now start being mainstream. So when multiple business units, multiple businesses can put data, all their data into the data reservoir and start playing with it, start producing reports, start making sense out of it. So it was absolutely impossible with the legacy system. So it's a new thing. So data processing. So it's also a change. It used to be, so it's a very sequential kind of processing of the data. So in a new way, you have parallel data processing is what it's all about. So with legacy, in order to achieve better performance or adapt new data, you have to buy more and more expensive hardware. With new way, you have to add those commodity computers, and you achieve your linear scalability. So that actually implies that it's a change in your infrastructure, how you do your all your design. Then the next one is development tools and technologies. So working with data, it's around data manipulation languages. And it's basically have all those, ETL, SQL is just one of the examples, but those will be similar approaches. With the new approach, you're able to use open source, which is actually plugged in, and it's seamless integration with new packages, which allows you to do statistical analysis, machine learning, and it has high-level frameworks which you can use, and you can use actually not only your data manipulation language, but you can use your standard languages, and coming up and kind of new generation languages allows you to actually have a higher performance for your developments, Clojure, Scala, or use traditional languages like Java, C++. It allows you to reuse some of those components and build extendable, flexible infrastructure. So, and business intelligence also changing. So before, used to work on limited data sets with low latency data platforms, and now needs to adapt to huge data sets utilizing new usage patterns, and it's a completely different way how you deal with those business intelligence platforms. So it used to be for business intelligence, like to make an example, you have a Tableau, for example. You can go directly to your database and manipulate and get all information, and the tool allows you to create right reporting. Now you have to adapt and create special patterns to be able to take the huge data set or filter it or prepare it using big data capabilities, and then actually be able to work with this data with business intelligence. So it's a different way how you integrate those business intelligence platforms with the data source. So next slide. So organization and talent. So it's a next challenge. Starting with analytics. So it used to be that analysts producing standard predefined reports or producing some metrics which are predefined, or in best case they're using some cubes, so they'll be able to slice and dice the data the way they want. So now the big data allows you, the analysts, to actually discover new patterns and find new business ideas, to use power of parallel computing, and then use all those open source or other tools which now you can really use, which is machine learning, statistics, and new profession of data scientists is emerging. So people who are actually able to make sense out of your data as it's seen by them. And for IT professionals, they used to create platforms which use structured data with very well-known patterns, and it's not at all, so it's sequential. So and the second one is data strategy, which is usually exists for particular business units, and it doesn't exist on an enterprise level because it's too difficult. Like you cannot really create one big data source, big data repository for the whole enterprise. So with big data, the IT professionals profession actually requires to change. You need to actually have solutions which support massive parallel processing, shared nothing architecture, and patterns which are to be implemented are still not still evolving. So they're not defined. And you need to now have enterprise data strategy, so it's a new skill again. And now talking about organizational design, it also needs to change. The analytic function, it used to be part of concrete business units, so it was a siloed approach. Now actually you want to work with your enterprise data, you need to create a central data organization, and actually with the right roles to address it on enterprise level. So if you want to create this data reservoir for enterprise, those roles need to exist to address data quality, retention, privacy, access control. So those are the changes which your enterprise needs to go through. So next slide. And talking about IT infrastructure.
When we talk about the IT infrastructure, it's all about how you're going to change your existing hardware, existing network grid, and with a completely new approach based on parallel processing. So first you change the specialized hardware, instead of using specialized hardware, normally vendor-specific, with commodity servers, which is extremely much more cheaper in terms of storage, in terms of processing, and you can find on the internet a lot of analytics where you see actual numbers, but our clients normally do very happy with the numbers they have with the price per terabyte. There's also a shift with the network, because before big data approach, you required a low latency grid network within your enterprise. Right now, you require high throughput network, just because you don't need expensive and reliable network components to for real-time interaction between the system. But what you need is to move high volumes of data between nodes. That's the only thing you need in the new patterns and ways to operate data in a big data idea. The very important question that I mentioned when I was speaking about the infrastructure is reliability, and this is a very important question because it's normalized, and the approach in making the system reliable in classic traditional IT landscapes is completely different from the big data. When you have your System P or HP systems, the reliability is normally vendor specific and designed, and is working by design.
Yeah, like saying for resilience or failover capability, previously you need to have hardware design, so it needs to be some application of hardware. Now with big data architecture, it's all software-based, so it's moving from hardware to software-based, but still it needs to be some of the issues needs to be addressed. The second one is disaster recovery. It's actually standard in your legacy enterprise, and it's not at all standard in big data, so it's still evolving. You still need to come up with a solution, and sometimes you need to write actually custom code to adapt it. And for data protection, it's even bigger problem. So where encryption and roles-based security models entitlement is available for all, big number of legacy platforms. For big data, it's again requires specific development, and patterns to do this are still not fully defined.
Next one.
Yeah. So should we maybe have questions before we start getting into case study, or?
We have a couple of questions. Why don't we take a few now? I guess the first one, is there any research being done by your organization on the return on investment of big data? For example, the real business value claim versus dollars versus total invested?
Yes, and it varies largely. So well, because it's a few business cases where you can use big data. You can do actually replacement of your existing processing of data, and then you can compare kind of dollar to dollar, because comparing apples to apples. For example, replacing some standard ETL solutions with big data solutions, giving you benefits which actually in numbers. So it's basically times of the previous solution. Of course, big data is not for everything, but again, for this ETL, it's one of the good examples. And I'm going to go through this in the case study. To give you concrete numbers, so I mean, I guess it depends on the use case, but we actually seen a lot of it. So it's coming from minimizing the software development, license costs, and actually the infrastructure as well.
So it seems like with, as you talked about, a lot of the requirements, for big data technology, organizational skills and talents, infrastructure. Do you find that clients are having difficulty and they want to justify all of that on the first project versus having kind of a vision for big data that doesn't necessarily saddle that first project with all those costs?
It's all about maturity of the organization. So I guess there is a common topic, understanding that big data is part of the technology or even business strategy, so it needs to be implemented. So people usually take or companies taking more strategic view adapting big data, because first projects, if you take it on its own, basically taking the say Hadoop and all of those components and trying to have a corporate build, trying to integrate with existing environments, it will be prohibitive cost for if it's a kind of smaller project. because you wouldn't start with a bigger project. It's a too large of a risk. So that's why it's for the first project, it's usually kind of a let's try it, let's see how it works, and then the whole thing starts. That's what basically people see the benefit and start implementing it across.
Okay, another question related more to infrastructure. Can each compute or worker node consist of virtual machine instead of a physical server?
Yep.
Okay.
Yeah. So it's I guess it's another topic which is worth discussing. It's talking about virtualization. Yes, there are solutions in enterprise to actually virtualize those nodes. And it could be also a physical implementation of the Hadoop and doing all those nodes and builds. But actually, enterprises are moving toward virtualization of those services, with actually adding software-defined networks to be able to set the right level of, say, data bandwidth between nodes in real time. So those things are actually emerging right now. Yes.
So why don't we go through the case studies, and then we can hit some more questions as we go.
Okay. So the case study is from one of the large, quite leading investment bank, and so the idea was to provide a solution to gather financial data across all business units and provide financial reporting. So provide financial reporting on an actually daily basis. For large firms, it seems like an almost impossible task. So you pretty much have to close your day every day for financial information. So it's a very challenging task. But now, talking about regulatory challenges, so your regulators ask you to provide this information online almost, right? But it used to be that this information provided every quarter. Now they want to see what's going on with the balance sheet and risk of the organization. So then the other question is, people want to have a way to be able to trust this information. So how to make it consistent across all those different systems? Because if you talk about the challenge which exists for this particular implementation, it's hundreds of systems coming in different frequencies, in the different modes, so it's batch, real time, or different formats. So all this information needs to be processed, it needs to be cleaned, it needs to be reconciled. There's all different rules apply to the data coming from different systems. And also, because the amount of data is quite large, and the limitation to close the day is there, so you need to actually process all this incoming data pretty fast. Otherwise, you won't be able to actually do it as required. So, so what the solution which was implemented is okay. It was Hadoop which was used, and for actually storing the final data and doing final calculation, currently we're using Exadata. For transformation of the data and validation of the data, it's XML and XSLT framework is used, and so basically, the solution provides lower cost of ownership. So it's no license cost. Of course, it's no free solution. So instead of paying platform for like license cost, now it's still a payment with some of the big data partners, which actually have a support for those things, and able to have a fixes sometimes even to core products. Then another benefit which the solutions have actually ability to for business users to see and define how data coming from those systems, because usually it was done previously by IT departments. Now it's actually with the business teams, so they actually they can start building trust to the data they get, and actually they can sign those balance sheets themselves. And also the data traceability. So you're able to see how the data transforms from data source into the target system, where and how it's enriched, so any mistakes are made. And actually you have tools to adjust this data and do some cleansing. So, and if you go to the next slide, so we can talk about some of those challenges, how they met. So, so the solution implemented Hadoop-based ETL, and some of those patterns were merged, and now that the enterprise implementing those patterns across multiple business units. And it was one of the first Hadoop implementation, but now because of this benefits which relates to your previous question, the company sees how they can cut on traditional ETL tools, how they can actually implement those ETL with much lower cost, actually processing huge amounts of data in this very complex rules. So that's actually one of the successes. Then the next one is seamless integration. So this particular implementation, it was replacing some of this validation and data aggregation modules, and actually seamlessly connecting to downstream and upstream systems. And then it's actually set the foundation and will start to replace those systems one by one. So it's not a big bang approach. So it will be replacing very methodologically, step by step, those systems. So the pattern is established. And the next challenge which we met there is that basically data encryption was not existent. So, and we need to put some of the custom code into the Hadoop core builds in order to actually address this. So it was one of the patches which was done. And so it's basically we have an encryption which is not used to be part of the standard solution, and also disaster recovery. So it's not part of the standard package. So it's implemented as an additional package, and it's actually comply with enterprise standards. And this, as I mentioned, the MapReduce data processing as a service which we established, we're now able to reuse those components, and those components are matched with business process. So like reconciliation, so it's actually a business unit which does reconciliation, validation, data cleansing. So, and those components are mapped into the particular business functions. And they can be reused, and this terminology start being used across the whole enterprise. And the last point.
One quick question. Before you go on, what were the data source types for this case study?
The data source was, it was relational databases, it was XML databases, it was some file patches coming from upstream systems. So those are the usually data sources which exist in a bank. And some of them are coming in message buses, so it's like enterprise message bus. Yeah.
Okay, thank you.
And the point which we're able to implement is a method-driven approach. As I mentioned, the definition of the data and definition of data validation and enrichment is defined by users themselves. So they actually have an ability to do it. So this task is given to them, as well as system allows to change the process of how you process the data using the big data standard tools for orchestration, UZI, and also using TIPCA as a standard enterprise orchestration. So we need to actually integrate UZI with the TIPCA layer, so to be able to comply to enterprise standards and use some of those enterprise architected services. enterprise orchestrated services. So any other question about this one? I guess one of the points which I want to make is that in this particular instance, and it's quite unusual because we've been following the adoption of big data in all different industries. Actually, taking Hadoop and having it to process financial data, it's quite a new task. Usually, it's more on like e-commerce or some modeling. But for financial reporting, where you cannot really lose your data, or you cannot really do mistakes, so it's kind of it becomes a reliable solution. So you do need to address some of those challenges in as I mentioned, to make it reliable and protected. But then actually those solutions start to emerge. So any further questions about this case study?
Then we can go to the next slide, please.
Yeah, next slide.
Yeah, so this case study comes from energy sector, and in energy, they are pretty classical guys. And among these three V's that we mentioned, they normally tend to stay with two, which is volume and velocity. But the data, the information comes into huge amounts and stored for ages. And that means that if we speak about the data that is stored, then it's really big data, and it's like hundreds of terabytes of historical data. If we speak about the sources of data and the variety of them, they're normally pretty much structured, but a huge amount of them. Imagine like millions of remote terminal units and other heavy devices hanging on the poles outside your house. All of them can send millions of records. The modern remote terminal units can send 20 message every 20 milliseconds. And each of this message, each of this record, actually can change the behavior of the grid, because within this message, information can exist about the new electromagnetic process, which is extremely fast. So it needs to be processed, centralized, and as fast as possible. And if you miss this piece of information, that means that you're losing your grid. And the faults within the electric grid are extremely expensive. That's why, again, we're talking about some unusual case of using big data platforms, because it's mission-critical solution that we're discussing. And here what we're showing is an example of that platform that is collecting the data from all the remote units which are distributed somewhere across the globe, and sending messages in unpredictable speed, because sometimes they're just sleeping and sending a message every second, but sometimes they're producing this huge amount of records several times per second, each of them, and there are millions of them. And add to that metering data, which you have to store for several years to find the trends. And you understand that the amount of data that comes in and is processed and stored is enormous. And here, where the traditional technologies are not used at all. Instead of that, they just forget about analyzing this data and try to aggregate as much data as possible, try to calculate it somehow. So using some other methods. But Hadoop allows us to analyze all this data in one place altogether and the speed enough to find these bad processes in almost real time and prevent technical and non-technical losses. And more than that, then you try to correlate things that were not able to be analyzed before. For example, historical metering data, weather forecast, and telemetry data, which now can be stored in one silo. Then you can find some completely new patterns, and you can change the behavior of the grid before the problem arises. And this is what this platform also allows to do. But what's also more important, then you have to think about non-sensitive data, but the data that needs to be used to analyze what are the devices that are best suited to different geographic conditions, weather conditions. You don't want to spend the enormous amount of money on that. And here, the cloud nature of the big data comes in. And all this infrastructure has been used in the cloud, meaning that utility does not spend any extra costs on analyzing things that are used not for everyday business, but for trying to predict what are the types of devices are best suited for different conditions, trying to find new patterns, new ideas of using devices in different conditions, different situations. So this is like a platform that Luxoft was developing for one of the clients.
Yeah, and I guess we can go. We have many of those solutions, but again, the challenges do remain the same. So it's Hadoop for enterprises. It's basically completely new technology and new techniques, development patterns which you need to use. Then you need to actually change your organization from just organizational design and also acquire completely new skills in technology and in analytics. And this new data scientist specialty is emerging. And you need to change your IT infrastructure, which is actually quite sometimes one of the most complex fees for those kind of new projects. So that's kind of where we see the most challenges. So, and if you now if you move to the next slide. So addressing big challenges. So we see the pattern, how big data adapted over and over again. So before, and it looks like it's very similar to every other projects. But because you're addressing all those three challenges almost at once when you're implementing the projects, there is a different approach to how you actually do this big data implementation. So you do identify the what the real business needs. Is it really big data problem or it's something else? And then resource identification of is it any gap within client capabilities? And then it needs to be kind of a budget for this, and it needs to be kind of a planning to not to make the whole big data adoption a failure, because it could be if you don't have the right people to take it forward. And also identification of benefits for big data. Sometimes big data is brought in to do something which is not supposed to be, and then people say it's actually a failure because people just want to try, and they see some mismatch, and that's it. So then first phase is first after business assessment. Then the stage with actually a team which includes big data scientist consulting. So then we actually do evaluation of all infrastructure, current infrastructure, the corporate standards. Then we see all this big range of data platforms and providers and say BI tools, and we implement the right one because, as I mentioned before, the patterns how to use big data with, for example, business intelligence are still being defined, and some new tools are coming up. Say for Hadoop or Cloudera, they're coming up with this Empower tool, but there are also some ways how you can do without it. So those are things that need to be implemented and standardized. Then the next one is architecture design. So that's now moving into more traditional way. So and you have specialists which went through this process many times, and there is a kind of a repeated process of those problems which we discussed. They're kind of we're meeting them over and over and over again. So addressing the infrastructure, people skills, and organizational changes. So if you move to the next slide, and it's the last slide. And then you do your normal development cycle. So software development, then performance engineering, it becomes a very important tool because it's a new set of tools how you actually do performance for this big data implementations. It's a completely different data set. How how you do your testing. And then implementation into corporate infrastructure, so that the actually support needs to be trained with the new technology, how they monitor it, how they raise the issue. And if you use some of our partners in big data space, Mataya or Cloudera, then those things need to be established. And sometimes we actually bring them into in the early stages, so then the corporation can actually have this specific solution in their own network. And then we actually get into the last phase where we either take it or we don't. So we do all level of supports, or we take one of the support like higher level where we do changes or do some developments, or we hand it over to the internal organization or to another vendor, which that's how it's usually done. So that's what our response to this, because the patterns which we see in big data is it's coming up all the time, all the same patterns, and we actually having a team of people who are looking at those emerging trends. They're looking at the issues which company facing, and they're coming up with those solutions. So we're able to address it. So you don't need to repeat mistakes of others, because that's your first failure could shift your adoption of big data, and that would be a loss for not only for transformation of IT technology, but potentially for business and your competitiveness. That's basically it. And so Luxoft, just briefly, Luxoft is a member of IBS Group, which is our holding company. But talking about Luxoft, we have most of our clients are Fortune 500 companies, and some of them are mentioned on the slide. So it's we have UBS, Deutsche Bank, and some technology companies, and almost every sector in these areas are looking to adopt a big data solution. Some of them are doing POC, some of them are doing real production implementation. Actually, a smaller portion of it just thinking about it. Most of them are actually acting at the moment. So I think that this year, next year, is going to be quite a change with the adoption speed. So before it was really a kind of proof of concept talking about it. Now it's a real implementation phase.
Can you talk a little bit about how should a organization get started if they're fairly new to working with big data? You mentioned maybe how could you guys help them accelerate doing those type of projects, but can you go through kind of an approach that would say, select a project or analyze the environment, or what do you typically do with a new client who's looking at moving towards this?
Yeah, so what we do is for every industry, it's a set of patterns or set of solutions which exist. And say in finance, it's fraud detection, or it's some data integration, or some pattern detection. So we basically take those patterns, and we have a conversation with the client about if they have a similar situation, and we show them how they can change from traditional way or traditional platform and use big data, and show them basically the kind of way there. So that's the first step. And once you over this, of course you show your capability and show some of your case studies, but I guess the biggest one is actually to show them examples which can relate to them. And I guess for each industry, for like majority of the industries, those patterns are pretty well established, and it's some new cases are coming up, and that's how we start.
From a skills standpoint, since this is relatively new, so I know skills are an issue. How do you work with clients to help them grow the skills internally? as well as utilizing your resources?
Yeah, so it's two ways to do it. When we implement the project, usually some people from the client team actually join our team. So it's learning on the job. And of course, before they join, it's some introductory courses. So there's some requirements for that, of course. But we do those trainings for our clients, as well as there are some of those trainings available from leading vendors. So that's the first step. And then as project goes on, so we actually create for support organization all set of those run books, and actually the team as it goes, it's expanded with more of the client staff if they actually decide to take it as an internal expertise. And the key, actually, one of the key skills is data scientist within the organization. So that specialist needs to stay within, I believe, because that person would eventually become quite powerful and needs to have an influence within the organization. So those guys need to be trained and retained. And I have to tell you that finding a data scientist which can understand the right on the right level of the industry is a challenge. It's a real challenge. So that's so we do have some training where we take our analysts and train them for big data technologies. Also, it takes months. So that would be one of the constraints to quickly adapt the big data across the enterprise.
Okay. Well, Vadim and Sergey, I'd like to say thank you for going through this topic. I know it's a lot of enterprises are looking at this today, and some of them have already engaged it and are using it strategically. But I appreciate you going through some of the challenges and opportunities, as well as talking through the case studies. I think it helped to make it more real and help give an idea of some ways that organizations get started. And your contact information is there on the screen. So hopefully anyone out there who has questions about big data, or where to get started, or how to get help, or what is a big data scientist, that and how can you develop that, I think you need to contact these guys. They're the experts and they've been through it already. And I'd like to turn it back over to David from the Outsourcing Institute.
Great.
Okay.
Thanks, Tony. I just want to thank everybody for the presentation and thank everybody who's listening in. I hope everybody has a great day, and thanks again.
Thank you.
Thanks.